Hi. So in this project we'll be looking at the book genre classification. As the name suggests, it classifies the or it predicts the genre of a book based on the summary of the book. It classifies, there are many classes which the model is trained on, that is a thriller, science fiction, fiction, history and many more. So let's look at the workflow of this. So first we'll load the data into the data frames, then we'll perform some pre-processing techniques, as this is a natural language processing task. So there will be many pre-processing techniques like stemming, lemmatizing and all, and then after that we will perform some exploratory data analysis on the stemmed words. Then after that we'll select the best machine learning algorithm which will fit the data, and then we will save that model weights, and then we will integrate that model with the web service, that is by using any web framework like Flask or Django. Then we will deploy our model on AWS EC2 instance. So this is the overall workflow of this project, that is book genre classification. Let's look at the working demo of this. So here is the working demo of this. So book genre prediction. So this is the information about the data set, where so you can go and directly you can just go over here and directly you can download the data set from this given link over here, or else I'll also provide the data set, and over here you can just download the data set from here, and you'll get the data. Then after that, let's look at the working demo of this. Let's for example, let's copy this everything and paste it over here, and let's hit on this predict button and see how this is predicting. So it is taking a little bit time, and if I just do a refresh over here, I think so things will go work. Yeah, so here we can see that the summary is classified as thriller over here. Okay, so basically it may take a little bit time, because at the backend machine learning instances are working, they are very heavy, and the load on it is little bit more. So when a huge chunk of text is been sent directly to it, it takes a little bit time to predict, and because of some load issue it may happen, but most of the times it will give the prediction correctly. As you can see over here also, the prediction was correctly given, because the first few lines were talking about something, talking about some historic events. Now let's completely do this and paste it over here and just hit predict once. So yeah, so now you can see it is thriller. Why it classified as thriller is right. This airborne toxic event is one event which is a chemical spill from rail release, and it just entered into someone's body's thing, and then over here at the end it is a way how over here a tricycle across the highway and miraculously surviving. So it is kind of surviving from a very big chemical spill, and then there is a lot of struggle which is happening. So it's almost a kind of a thriller only. So it is perfectly classified it as thriller. So in the next video we'll look at the building of this project. So in the last video we covered about the introduction part of the book genre prediction or book genre classification project. We saw how it is predicting it as thriller and all. Now we will look at the building of phase of this project. So these are all the dependencies which will be required. So first we'll require pandas for data frame and all that stuff. Then we'll require NumPy for numerical computation, Seaborn and Matplotlib for plots, Re and NLTK regular expressions will be required for processing the text. NLTK is natural language toolkit, which is a very mandatory library for all the natural language processing task. And then we have this from collections we'll import the counter, and then we'll import the TF-DIF vectorizer, count vectorizer from a feature extraction, then train test split, then decision tree classifier from sklearn tree and all. So these are all the these from sklearn import from sklearn.tree import decision tree classifier and all. These are all the machine learning algorithms which we'll be using. These are the pre-processing algorithms which we will be using. These all are the pre-processing algorithms which we will be using, and these are all the basic dependencies which we will be using for plotting and doing some normal computational task. So let's import those, and then let's import the data set. it will take a little bit time because there are more dependencies over here. Now we'll import the dataset and we'll look at the head of the dataset. Now we are already only interested in the summary part. We are not interested in any of the other columns. We just need genre and summary. Okay, but we will keep the book name and book ID if there are any kind of some exploratory data analysis which we can do on them, but our major focus will be on summary. So summary would be our training part and genre would be our testing part or the dependent variable, and summary will be our genre will be our independent variable and summary will be our independent dependent variable. So we'll choose the things which we need. We'll drop the unnamed column. We'll look at if there are any null values. There are no null values over here. We'll look at the count plot of genre. So there are almost 500 each genre is having 500 books or 500 genres. Each summary is classified into 500 different types of genres. So let's look at the summary. Let's look at the length of the summary of the first part. Over here we can see so as you can see that there are a lot of punctuations, there are a lot of unnecessary characters like this which we have to remove, right? And there are the overall thing is also not correct. Everything is like in capital and all, so we need to correct that as well. So what we will be doing is basically we will be defining a clean text function which will use regular expressions and which will remove all the special symbols, punctuations and whatever the things which are not required in our case. So it will take in a parameter known as text. Now the text we will use this re.sub. This sub is basically a substitute. So re.substitute will substitute this black slash with an empty string over here, and then we will pass in the text value. So wherever you are having this kind of thing over here, it will be replaced with an empty string. So this will be handled over here. Okay, so this kind of things will be handled, and then we'll remove the special symbols. So if there are any kind of punctuations or any kind of question marks or exclamation marks or anything of that kind, that all thing will be removed with the help of this regular expression. This regular expression basically says except characters from A to Z or capital A to Z, replace everything with this. So if the character is in between A to Z, that is small a to small z or capital A to capital Z, you include them. But if there are characters like comma or question mark or exclamation mark or all the punctuation symbols and all, just replace them with a white space. That is the meaning of this regular expression. Then after pre-processing, after cleaning the thing, we will join our we will try to make our text into a single text. That means we will try to basically what will happen is these all will be removed with spaces, right? So there will be extra space left. So in order to make everything clean and neat, we'll join them and then we'll make it into a single clean neat string. Then we'll convert everything into lowercase so that it's easy to process, and then we'll return it. So this is the entire function for cleaning the text, and then we will be applying a lambda function to it. So this lambda function will basically say for every summary in this books of summary, you apply a function named as clean text. It's as simple as that. For every for this this lambda x represents for every summary in books of summary, apply clean text of x. So that will do an inline computational task, and then after that we can look at one of the results. So I'm looking at first result over here. So as you can see, every punctuation mark and everything has been removed. Wherever there was comma, wherever there was apostrophe, and everything which was present here has been removed. Even full stops are been removed, and just we are having a lowercase string over here, lowercase chunk of text. That's it. Now basically if we try to show the distribution, if we try to look at the count plot of this, we will get to know some very good insights from here. So we will be plotting the most frequent words. So most frequent words, to plot that we will define a function known as show most frequent words, which will take in the text, which is nothing but the text will be in this kind of this will be the summary which will be passed to this function in a form of a text. And then the number of words are basically how many means how many words count do we need to see, that is the number of words. This is user defined, anything can be given by the user itself. So first what we will be doing is we will be joining everything into a particular, we will be joining everything into a whole single text, then we will split it. Okay, then we will split it, then this all words dot split will become a list of words. That means this text, for example, if this is the text, if we split this will become a list of words like as, comma, the, comma, book, comma, opens. It will become a list of words. On that list of words, what we are doing is basically we are applying a nltk.freq_dist. So this freq_dist is nothing but a type of a counter which is working behind the scenes. So freq_dist is nothing but frequent dist. Okay, the words which are occurring frequently, please maintain a count of them. So in NLTK library there is one counter known as freq_dist, so we are using it and we are passing the all words. So this fdist will basically give me the dictionary of the frequency of the words which are occurring in the text. Okay, so now what we'll do is we'll try to make a data frame of that. So we'll say word list of fdist.keys. So this word will be the words, those are our key values, and the count of them will be the values. So for that we are saying count is equals to list of fdist.values. So this data frame, so this dictionary is basically converted into this pandas data frame with the help of this simple pd.dataframe method. Now what we'll do is we want to see the top n number of words. That means for example over here I gave 25, so top 25 occurring words I want to see. So for that there is one method known as n_largest. So we will be looking at the n_largest method on which column? We are looking on the count column, and n is equals to number of words means we are looking for the top 25 words. So df is equals to words df dot n_largest of that thing. That means this will display the data frame of the top 25 occurring words. Okay, then this plt dot everything is nothing but this is a count plot or a kind of a bar. This is a bar plot which we are plotting. So this is the figure size which we mentioned, and this is the bar plot where we'll take the data is equals to df, and then x is equals to count and y is equals to word, and then we'll set the label as word, and then we'll show, and then we are returning this words df so that we can do some other kind of processing tasks. So words df is equals to this thing. So if I just execute this, the plot will be visible. Yeah, over here we can see that these are all the stop words which are there. The, to, and, of, is, her. So this is not which we want, because these words are known as stop words and they do not convey any kind of meaning. We want all meaningful words rather than all the stop words. So we need to do some kind of processing, more processing on this, like stemming, lemmatizing, and removal of stop words. So we will look at one of the so as I was saying that this was the bar plot representation. If we want to look it in the form of a data frame, we can use this words df.sort values. We'll sort the values based on count, and we'll say we want to sort it in descending order, and please showcase the first 10 rows to me. So if I just execute this, it will showcase me this. So we can see that the, to, and, of, the, to, and, of. So in this, if it is not clearly visible what is the exact count, we can look at this thing, right? So this was all about this, and in the next video we'll look at how to remove these stop words, because these are not giving any kind of meaning. So we want words which are giving some kind of meaning. So in the next video we'll look at the removal of stop words. Hi. So in the last video we saw how the distribution was affected with the help with these stop words, because the stop words were the majority, the stop words were contributing in majority, and we want to kind of remove the stop words because these stop words do not convey any kind of meaning to us. So we will be using NLTK for this. So basically over here, if we are having this, we have to download the kind of stop words first. So first what we'll do is we'll use this nltk.download stop words. So basically what will happen is we have to download a set of stop words first in order to pre-process the tasks. So what I will do is I'll just type in over here, and I will type in download, and I will press shift tab over here, and you can see the download directory over here, right? So this is the option which I will be selecting. So download directory would be my home directory or the directory in which I am working. So if I just write dot and write slash, I'll get all my all the files which are present in the current working directory. So I want to download all the stop words in this directory only. So for that I have to mention the download directory specifically. Now if I shift enter this, it will download all that, and I'll just show you how it will look like. So over here what it showed, over here it displayed that, over here it displayed stop words, and download directory is this, right? So this is the corpora, and over here we are having the stop words, and over here we are having stop words for every single language which is present. Like not every single language, for many languages we are having the stop words. Like for English, if we want to see the stop words, we can click on this and edit as notepad, and we can see the stop words over here. Just it will take a little bit time because there are many stop words which are present in back of the scenes. So over here we are having these stop words. They are almost like 180 stop words which are present. So for every language you can see the stop words, right? So we will be downloading those stop words, and then after that we will be using this corpus from NLTK corpus. That was this corpus over here. This corpora is they were the corpus. So from NLTK corpus import stop words, and then stop words dot words of English. So basically it will go inside that file and it will gather all the stop words into this set. Now why we are using set? Because there may be some stop words which are repeating, so we want to remove the duplicated stop words. We want all unique stop words only, so that's the reason why we are using the set. Okay, so all the stop word set is mentioned over here. Now we will be removing the stop words. We will define a function to remove the stop words. So what this is doing is, this text is a huge chunk of example, this will be a kind of text which will be passed to this function. So in this function what we need to do is, we need to separate them word by word, right? So we need to separate them word by word, means we will do word for word in text dot split if word not in stop words. So that means, what is the thing? Text dot split means basically it will split the text into words, and for every word we will check whether that word is present in the stop word or not. If the word is not present in the stop word, then only we will use that word, right? Otherwise we will not use the word. So basically this is a kind of removing all the stop words. So that is why it is named as removed stop word. After that we will join the all the words to make a sentence using this join function, so that all the stop words will be removed. Now we will be applying this, we will be using a lambda function for applying this, right? So books of summary is equals to books of summary dot apply lambda x remove stop word of x. This means that for every, this lambda x means for every summary in books of summary you apply remove stop words of x function. Remove stop words of x function. So this will basically return me a sentence which will have all the stop words removed. Now books of summary dot ilog of 1, just in order to check whether it is working fine or not. Yeah, we can see over here all the stop words were removed because the length of the sentence has been reduced. Over here the length of the sentence was big, was huge enough, but over here the length of the sentence is comparatively less. So that means all the stop words have been successfully removed. So we'll be using this method to remove all the stop words. Now the next process is, we'll be using this lemmatizing thing. So basically lemmatizing is nothing but it's a kind of giving a priority to some synonyms, antonyms or similar kind of words. So we will be using the NLTK library for downloading the WordNet over here as well. So if I just press download dir over here, download dir and dot this, if I keep, it will download the NLTK, it will download the WordNet zip file into the existing working directory of mine. So if I just go over here and go to corpora, I can see that I get this WordNet over here. So if I just go and check at the WordNet, I'll be looking at so many things over here. So data.verb, index.verb, noun.exe, lex names, adjectives and nouns, everything will be given over here. As if you are interested in learning all the license and everything, you can read all this. And over here we are having some kind of mathematical denotions for all these simply kind of words. Okay, so lemmatizing will surely what it will do is, it will kind of skip all the words which are giving same kind of meanings, and it will convert it into a single word. For example, we say that lemns we said it running, runs, all those. So it will convert those all convey the same meaning, right? So it will take a single root word and it will truncate all the other similar kind of words. So that is the meaning of lemmatizing. So we'll define a function known as lemmatizing. So we'll say stemmed sentence is equals to an empty string. So for every word in this sentence, we are applying the lemmatizing function, that is lemma.lemmatize of word, right? And then we are adding to this stemmed sentence, and in order to make the sentence look good, so we are using this stem sentence plus equals to white space, so that the sentence is properly organized. And if there are any kind of extra spaces which are left, we will be removing it with the help of the strip function, and then we'll be returning this stem sentence. So same as before, we'll be applying a lambda function to this so that it's inline for loop. So we'll be using books of summary dot apply. So for this lambda x means for every summary in books of summary, apply lemmatizing of x. As simple as that. So how to go forward with lambda functions is lambda x for every summary in books of summary, apply this function, right? So if we just execute this will execute it. This will take a little bit time because this NLTK WordNet is a very big file, and this function will also take time because there are many summary sentences which we are passing. So yeah, it's already done. Now the next thing after lemmatizing is we have to stem the sentences. So for stemming, we will be importing a library known as Porter Stemmer, so which is present in nltk.stem. Then we will set a object of it like stemmer is equals to Porter Stemmer, and then we'll define a function. Defining functions are very important because it will directly do the task for us. Just we need to use the apply function over here, as we are doing in so many cases above as well, right? So in stemming, what we'll do is we'll define a function named as stemming, which will take in parameter this sentence. Now this sentence will be of this kind. Okay, the sentence will be of this kind. So we have to split the sentences. So split the sentence into words so that it can be stemmed. So what we are doing is we are saying stemmed sentence is an empty string. For word in stem sentence dot split, for every word you apply stemming algorithm, and then after that algorithm is applied, the result will be stored in the stem. Then you add that into this stemmed sentence empty string, and then in order to make strings look prettified, you add a space over there. So stemmed sentence plus equals to space, right? After all this, what we need to do is we need to strip it if there are any kind of white spaces which are left. Once all this is done, we will be returning the stemmed sentence. So this function will return all the this function will remove all the stemming, and this function will perform the stemming pre-processing, and then it will return the stemmed sentence. Now if you look at so this is the lambda function which is working behind the scenes, and then books of summary dot iloc of 1, if I do, you can see over here one very important thing. After the stemming, how the sentence will look like, after the stemming, how the sentence will look like. So it is working. It will take a little bit time, and once it is done, then we can display it. So it will take little bit time because stemming is little bit heavy at the back end. Because for example, I'll showcase how the things will work. For example, we are having this enable. So this enable 2 or 3 characters will be removed from back, and U and AB will be showed. For example, we have remember, so E and R will be removed from the back, and the other part will be shown. So over here you can see this enable is there, so it just removed the last E, and then only the first top 5 characters are being kept. Over here we were looking at the bus, so it removed the last character, that is S, and bus was there. In some situations it will not remove, but in some situations it will remove. So this stemming algorithm is the Porter Stemmer, which is used behind the scenes. So this was all about lemmatizing and stemming. In the next video we'll look at further suggestions and further pre-processing tasks and model building tasks. Thank you. Hi. So in the last video we covered about lemmatizing and stemming. That was the most important part for our entire pre-processing task. Now we will do some kind of analysis over here. In the previous video we saw, in the previous few videos we saw that there were the stop words which were dominating. Now as we remove the stop words, we stemmed the sentences, we lemmatized the sentences. Now the plot would look something different. So if we try to plot the plot over here, we'll be having a whole different kind of plot. So over here we are seeing this, the instead of to, the, and all, so we are having some words which are conveying some kind of meaning, like father, murder, become, return, also, life, to, time, and all. So yeah, this is an indication that we have successfully stemmed, lemmatized, and removed the stop words. And now if you look at the count of them, so we will see that the one keyword is occurring more number of times, find is occurring next, kill is occurring next. So maybe, yeah, so there are few words which are occurring more than once or more than 1,000 times in this. So these are not the stop words, and in short these are not the stop words. So that is a clear indication that our pre-processing tasks are perfectly done. Now we will do the encoding task over here. So if we just look at the list of books of unique, so that means we are not having so basically we are having all the categorical variables, right? So if we just look at the genre, if we just look at the genre of books, we are having this fantasy, science fiction, and all. We need to label them. We need to label these, right? Why we need to label? Because machines can understand only numerical terms, so we need to do some label encoding to this. So what we are doing is this function is doing the label encoding task. Over here we can see that this function is converting this is one books list, which is this list, and this is an encode list, which is just 0 1 2 3 4 5 6 numbers, and then we are zipping these two lists to make a dictionary. So this will make this kind of thing. So now what we need is we need to map wherever it's fantasy, we need to keep it 0, wherever there is science fiction we need to keep it as 1, wherever crime fiction we need to keep it as 2, like that. So what we will be doing is books of genre is equals to books of genre dot map of mapper. So this will be using, so this will map. So in the books of genre column, wherever there are fantasy, map it with 0, wherever there is science fiction, map it with 1, like that. This entire statement is meaning. So if we just execute this, we are saying that now unique values are, instead of unique values being fantasy, science fiction, and all, the unique values are 0 1 2 3 4 5. Now we'll look at the model building phase. So in model building, we have to convert the summary value into an count vectorizer, or the vector in a vector format. So for converting the sentence into vector format, that is basically the numerical representation, we'll be using this method known as count vectorizer. So in count vectorizer, we'll say max difference is equals to 0.90, min difference is equals to 2, max features will be 1000, and stop words will be using as English. If there are any kind of stop words, just remove those stop words. That is the meaning of this. And bag of word vectorizer is equals to count vec dot fit transform books of summary, right? Count vec of fit underscore transform of book of summary. If I just execute this, it will return a sparse matrix for me over here of 3000 into 1000 dimension. Then we will as we all know that, as I said in the starting only, the summary we will be using it as training, and then testing for, and our dependent variable will be and our independent variable will be the genre, and the independent variable will be summary. So we are saying test is equals to books of summary, and we are applying train test split, so that the data gets split into test training and validation. So if we look, 2400 for training and 600 for validating. Now we will try to fit some algorithms on this. Now let's start off with multinomial NB, because this is very fast and it works very quickly on text data. So it is giving me an accuracy of 65%. Let's see out with random forest classifier. It will take a little bit time, and the reason why multinomial NB, that is multinomial naive Bayes, is working good is it will not understand the context behind the scenes. It will just see where it will work on basis of counting. Like basically, if these words are occurring more, so these words will get priority, and then these words will get some kind of distribution in the end. So in cases of text and everything, multinomial naive Bayes and Gaussian naive Bayes or linear models like support vectors also work good. But when it comes to random forest classifier and anything, it will not work good, because over here you can see this keyword named as sparse matrix. So in sparse matrix is a kind of matrix which will have a lot of zeros. So in random forest classifier, if when we are calculating the impurity or gain behind the scenes, as random forest classifier uses decision tree, behind the scenes impurity has been calculated, like this, information like entropy or Gini. So when that is calculated, when it reaches a value of 0, that means the node is ended over there. There is no further node which is proceeding. So in decision tree or random forest, many of the nodes which are not so much of the information which is to be conveyed is not conveyed in the algorithm itself. So that is why these algorithms do not work well on this. Boosting algorithms can kind of work well, because boosting algorithms work on the main fundamental thing of boosting algorithms is they work on the previous iteration. They try to fix the errors which were there in the previous iteration. So that is the basic difference of boosting algorithms and ensemble algorithms. So while coming to support vectors and multinomial, these are all the linear models which will use some high dimensional data analysis, and will do a certain will work on distance parameter mostly. So in high dimensions, calculating distances like a Euclidean, Minkowski and all, it's very simple for these algorithms. So we saw that the accuracy scores are not good, so we will try to use some other vectorizer over here. Instead of count vectorizer, let's use some TF-IDF vectorizer. So now what we will be doing is we will be using TF-IDF vectorizer. So what we will be doing over here, we'll use sklearn. From sklearn we'll import label encoder. So in order to give the mappings of them, this book genre, we'll import the label encoder. Actually this step is not required, but because this step is already done over here, that is we are already mapped, but it works fine even if you don't want to do. After all, the result will be the same only. Xtrain, Ytrain, Xtest, Ytest. If you just try to do train test split on books of summary, which is our training, and Y, which is our books of genre. So if we just do train test split on this, we'll get the training and validation data, and we see that, and then we'll be using this TF-IDF vectorizer over here. So TF-IDF vectorizer will take maximum difference of 0.8, maximum features will be 10,000, and then we'll fit underscore transform on Xtrain and only transform on Xtest. We will not use fit underscore transform on Xtest or validation data, because understand a very simple difference between fit underscore transform and transform. The fit underscore transform will consider the label as well along with it, and with that it will use the distribution and it will fit it, right? Whereas transform is basically we want to check whether our validation data will perform great or not. As we are trained our model on training data, we need to check whether it is correctly validating on the validating data or not. So for that the reason we will not use fit for that. If we use fit for that, we have to consider the labels of those validation data as well. So that will not make any sense, because model will learn the entire thing at once. So basically we need to separate it into training and validating. So that is the reason why we will use fit underscore transform and transform. Now if we execute this, it will take a little bit time and it will return me the Xtrain TF-IDF and Xtest TF-IDF. So that will be a sparse matrix after all. So this is the support vector classifier which we are defining, and we are passing in the training data, and we are predicting on the testing validation data. This will take a little bit time, because support vector classifiers internally use a lot of computation. They will use the kernel trick, which is the kernel may be RBF, linear, polynomial, or many kernels are available in support vectors. So they will be using all those kind of kernels, and behind the scenes all the computation has been done. So over here SVC, so basically TF-IDF vectorizer gives I think so good results, because it is using some kind of mathematical formulas back of the scene. So we are saying that it is giving 77.5% accuracy. If we are using multinomial NB, it is quick. As I said that it works on counting logic. So here it is giving 78% accuracy. So we can see that there is a shift from this, there is a high shift from this count vectorizer. If we are using count vectorizer, we are just ending it up some 66%, but if we are using TF-IDF vectorizer, we are ending it up some 78% accuracy. So you have to always try and look for other methods, because by trying some other methods we can get some good results, as we saw over here. So in the next video we'll cover about the testing of those model, and then we'll look at, and then we'll try to integrate everything into the Flask. Hi. So in the last video we covered about how we can change from count vectorizer to TF-IDF vectorizer, and we can see a very good increase in the accuracy score. Now in this video we'll test our model. So for testing our model, we'll define a test function and we'll apply all the methods which we applied from starting. So we'll be applying the clean text method, which is present over here in the start clean text method. We applied clean text over here, and then we'll apply stemming. We'll apply the stemming method, that will apply the remove stopwords method, will apply lemmatizing, will apply stemming. So all these methods will be applying at once now. So text is equals to clean text of text, it will remove all the punctuation, special characters and all. And text is equals to remove stopwords of text, it will remove all the stopwords from the text. Text is equals to lemmatizing of text, it will lemmatize all the text. And then text is equals to stemming of text, it will stem the entire text. So after these 4 steps, we will have the pre-processed text. Now on that pre-processed text, we will be applying a TF-IDF vectorizer. So we will be applying TF-IDF vectorizer and we will get a text vector. Now this text vector is the thing which will be passed to our model, that is model.predict of text vector. So if we now this model.predict will return me the class of the text, like what class does it belong to, right? Then we'll return the predicted. So we'll apply this, the lambda function is there. So in answer we will be getting this. So it will take a little bit time, because there are because 3000 or 4000 summaries are being passed at once to this test function. So this lambda function is basically an inline for loop. So this basically means lambda text, that means for every text in this book, for every summary in this book of summary, you apply this function, that is test text of text comma NB, right? So this will take a little bit time. And yeah, so what we will be doing is basically we will be getting classes like 0, 1, 2, 3 and 4. So we have to kind of map them over here, right? So for mapping them, we have to use some kind of logic, so that we can map this zeros to fantasy, 1 to science fiction, 2 to crime fiction and all. So over here we can see that we are having this 0, 0, 0, 0 over here, right? So this is a NumPy array. So if I just look at any one of the index over here, so if I just type ANS of 0, if I type, I will be getting a NumPy array of over here. So if this is a multi-dimensional list, so I have to type double braces over here, so that I can get the exact index or the exact class of the thing. So now over here what I will do is I will kind of this is a kind of function, this is a kind of method which will kind of switch keys and values. Okay, so this will kind of switch keys and values. So basically what we will be doing is we will be executing this. So in the predicted geners you will be looking so in the predicted geners, if you see predicted geners will be fantasy and everything is there. Basically what happened is this 0, 0, 0, 0 is converted to this fantasy, science fiction and all. How it is been converted is based on this mapper only. So this mapper, so over here we are switching the keys and values basically. So if we want to switch the keys and values, we'll be using this method over here, that is list of mapper.keys, list of mapper.values dot index, list of index val. So this is a method which is used for switching the keys and values, right? And I think so this is a little bit complicated, so for making it simple we can use this. This is the very simple way. So if you want to convert a dictionary, if you want to swap the keys and values of a dictionary, we can use this method, like value comma key for key comma value in mapper.items. So this is a list of tuples. Okay, so this is a list of tuples, and in order to convert a list of tuples we can use dictionary directly. So directly we can see over here fantasy 0 has been swapped to 0 fantasy. So this is a simple way of converting this, and then we'll be applying this, and we'll be getting the I'm sorry for that, I didn't execute it. So we'll be getting the actual genre and predicted genre over here. Then we'll be selecting the required things which we want, and then we will be getting the book name, summary, actual genre, predicted genre. Then we'll see how many were actually corrected. So actual count were these many, and then we'll look at the predicted counts. So predicted counts were these many, right? So there were these many predicted, and these were these many actual counts. So this was all about from this thing. And then if you want to kind of plot plots, you can plot it. It doesn't mean anything because it's just a graphical representation of the simple counts which we are getting over here, right? It's nothing more than that. Then what we'll do is we'll import, we'll save our model. So as we are using the multinomial Gaussian base, so sorry, multinomial naive base, we'll be using this to save our model. So we'll save it. Okay, once we save that model, we'll save even the TF-IDF vectorizer thing, so that it's easy for us to directly jump into the Flask code and use them. That's it from this testing model. In the next phase, we'll be looking at integrating the code with the Visual Studio, that is the Flask server. Hi, so in the last video we completed our entire stemming, lemmatizing, removal of stop words, creating an TF-DIF vectorizer, and then finally testing our model on some various textual summary, right? And at the end we saved our model weights as we saved our model weights as book genre model.pickle, and we saved our TF-DIF vectorizer.pickle. Now in this video we'll link, or we will unpickle all those things which we have pickled into production with the help of this Flask app, right? So basically we'll be using Flask framework for deploying our for creating our web application. So first we will import all the dependencies. So all these dependencies from NLTK, they are just copied from here. Okay, import NLTK dot stem, all these are copied. These are the basic NLTK libraries which are used for pre-processing. We use pickle file because we have to unpickle the pickle files which we created over here. And then we have this regular expressions library, we have natural language toolkit, and then we have the Flask. Now what we have to do, these are the common things which we have to use, because we are using stopnets and wordnet we are using stop words to remove the stop words from our text, and we are using wordnet for lemmatizing our texts, right? So what were the most important features which we did in our testing? In our testing we did this features, right? Clean the text, these were the functions which we used: clean text, remove stop words, lemmatizing, and stemming. So all these functions are copied and pasted over here. So you can see def clean text, this will take text as a parameter, and everything is same as defined in this function over here, right? Over here same thing is copied and pasted in this app.py file. Similarly, going to remove stop words, we have copied from this. For removing stop words, we have copied this function and we have pasted over here. Similarly, for lemmatizing, we have copied this def lemmatizing function and pasted over here. And for stemming, we have copied the same stemming function, def stemming, and pasted over here. So these were the four important things. First is removal of stop words, then it is lemmatizing, then stemming. First cleaning the text, then removing the stop words, then lemmatizing, and then stemming. So all those four functions are copied from there and then pasted over here. Now the important part over here is this text test library, or the test function, which we have defined at the end, right? So this test function is a kind of summary to everything. So this test function is, as usual, the first 4 lines are copied, and then then we are creating a vectorizer out of it, and then we are predicting the thing. Now we are keeping a map over here because 0 this predicted will be anything from 0 to 5. So we do not want numbers, instead we want the class or the genre name, right? So basically in the last so basically we used to do label encoding over here, right? So we did label encoding over here for our genre column, which consisted of these elements like fantasy, science fiction, crime fiction and all. So we are creating a mapper. So if this predicted is 0, then the class is fantasy, or the genre predicted is fantasy. If predicted is 1, then the genre predicted is science fiction, like that. And then what we are returning from this function, we are returning predicted of 0, right? So this predicted will be a numpy array, and from that numpy array we want the first index, so that is why predicted of 0 over here, and that from new mapper of predicted of 0 will return these things, right? So this is all about the test function from here. Now we have covered all the 5 important functions, and now these are just the opening of the pickle file, that is we are just unpickling the pickle files. We are just loading our model and our TF-IDF vectorizer, because we have to pass our model and TF-IDF vectorizer in this test function, right? So this is all the preliminary things which we have to do before getting started with the Flask main Flask code. So the main Flask code starts from this route. So we are basically giving a particular route over here. That means this is nothing but slash is nothing but home page of the entire website. So this app.route, we are creating a route at that slash point, that is nothing but the home page, and that route is taking two kinds of messages, that is two kind of requests, that are get request and post request. Now under that route we are defining a function named as hello world. So if request.method is post, if there is some kind of data which is coming from that form, from this web page, basically from this route, if there is any kind of data which is coming, so that is basically done or handled with the help of a post request. So if there is any kind of a post request, then what we are doing is we are storing that data in a mydict variable, and then we are taking up the most contextual thing out of it. That means what we are desiring from the data we are taking out. So we want this mydict thing, so we want the summary from it. Why we want summary from here? Because if you look at because if I show you the index.html over here, in index.html over here, if you can see the name is equals to summary. So this text area has a name as summary. So the text area is basically this one. Okay, this is the text area. So we are categorizing that text area as, we are giving a name to the text area as summary. So I want the data which is filled in that summary text area. So I am accessing it with the help of this. Now what I can do is I can pass the text whichever the user has written in this. Whatever the user has written in this, I can pass in. I can store it in a text variable, and then I can pass it to this text function. As I have already unpickled the model and the TF-IDF vectorizer, I will be passing them as well. Now what will happen is I am returning render template. Once the prediction is done, it will render the template, and then genre is prediction, and text is str of text, in order to show what was the text which was selected by the user. Okay, and then show result is equals to true. Now if you go to index.html, there is one Jinja formatting syntax which is if show result. That means if show result is true, only then this template will be rendered. Okay, so if show result is true, only then this div will be rendered. What is this div? This div is basically the result. So you can see over here, your summary is the text which you are passing from here, that is text is equals to str of text, that is nothing but the text which the user has written. And what is the next thing over here? The predicted genre for the summary is, so you can see the genre over here. So this genre is the prediction which we are making over here, right? So it will be more clear once if I showcase you that, right? So let me just save this over here. Once I save it, it will reload the thing. Now once it completely reloads, now I will copy this entire thing from here. I will copy and I will paste it over here, and then I will hit predict. I'll refresh it. Sometimes this takes a little time, but not always. So yeah, you can see over here this got predicted as Thriller over here, right? So this is the entire text. Okay, so this text is nothing but, you can see these 3 dots. Where are these 3 dots mentioned? In the index.html I have mentioned these 3 dots. Now pre to that 3 dots, what is this? This is nothing but the text, right? This is nothing but the text. From where is this text coming? This text is coming from this app.py file. So data is flowing from Python file to HTML file, right? So from Python file I'm sending text is equals to str of text, and with the help of Jinja markup I'm displaying the text over here. And similarly it goes with the Thriller, it goes with the genre also. So here over here you can see that the predicted summary for the summary is Thriller. Now you can see this is of different color, right? So over here what is of different color? This span tag is of different color, right? So that is which is in red in color. So this genre is getting printed over here. So from where this genre is coming? That is coming from this app.py file, right? So that is how the communication between the app.py file and HTML file is done. So this result will only be shown if result is true. When this if result is true, when show result is true. If show result is true, only then this will get displayed. So basically if my request is post, only then I can showcase it. Otherwise I have to showcase the normal HTML file only. So if I refresh this, I'll get the normal HTML file only, right? I'll get the normal HTML file only, right? So that was all about the Flask app. It was very simple. Nothing was there in this. Basically we just need to copy and paste it. Whatever the functions we have defined in this Jupyter notebook, we just had to copy them and paste it over here, because they are just straightforward. And then we just need to do some unpickling of our models and files, and then we have to transfer the data from the we have to select the data, we have to get the data from the form, and then do some pre-processing, and then fit a model onto it, and then render the result on the same index.html page. That was all to this. And this template is also very easy to code. There is nothing into this. The most important part over here is this text area part, which I covered now, right? Thank you. Okay, so today we'll be looking at the architecture of the cloud. Basically we are going to deploy our application of book genre prediction on AWS cloud. So before starting all about that, we have to understand some very basic things about the AWS architecture, how it is working and all. Okay, so now let's see that. Okay, so we are having our application hosted on our local machine. Let's say this is our local machine over here, and our requirement is that we want to share our application on the web, right? So this is the web, which is nothing but what? A connection of similar kind of computational devices which have browsers in it. So the request which I'll be sending through my computer will be displayed over their browsers, and the browser will respond, and the response will be in the form of my website. So this is the web. Now how to do this? Basically I want to share my work with the help of a URL. Okay, with the help of a URL. So with the help of a URL I want to share my work. What is URL? Unified resource location. With this unified location I want to share my work with the web, which is nothing but a collection of so many computational devices like computers, laptops, supercomputers and all. So how will this URL get generated? That is the important question, right? So how will the URL get generated is basically when I want my system, when I want contents from my system to go to the web, I use some middleware over here. So this middleware which provides me computational power is cloud. Okay, this middleware which provides me computational power is cloud. Now what is computational power? So basically when two computers need to communicate, that can be possible with help of some addresses and key value pairs. That is it. They can transfer messages, but they cannot do computational task. What is a computational task? Like calculating, let's say, basic mathematical functions, or let's say how your program runs in your local system. That cannot be done while you're transferring the messages from one system to other system within the system itself. So what do I mean to say is, suppose that there is one person over here, he wants to communicate with some other person over here. Okay, so now if person and person wants to communicate, they can communicate either with the phone, right, with the phone, or with a nowadays we are having digital media, like we can use WhatsApp or Instagram or all. That is all fine. But what if this person is a computer, if this is a computer and this computer wants to communicate with this computer by sharing some resource which is performing some computational activity, let's say like machine learning or deep learning or blockchain or some other activity which requires some kind of processor. So that is not possible in case of vanilla network. So we need something which gives us a lot of computation, which gives us a lot of storage, which gives us a lot of maintenance, which gives us a lot of scalability, which gives us a lot of reusability, which gives us a lot of reliability, all the terms. So all those terms are provided by this giant known as cloud. So this cloud which we are using today is AWS, that is Amazon Web Services. So present day AWS is dominating the cloud market by almost 45% or 50%, because it is providing a lot of computational resources. Okay, so now how local system can interact with cloud? What will this cloud after all give me? A cloud after all will give me an DNS IPv4 or IPv4 DNS or IPv6 DNS. So this IPv4 is a public IP address. That means the code which I wrote in this on my local system, I pushed my code onto the cloud, and the machine in the cloud is running my code. The server in the cloud is running, and it is providing an IP request which is nothing but DNS IPv4. So this is what is the URL which I say. So you got to understand that this cloud is a collection, a hybrid collection of many servers which is connected in some kind of fashion. So let's say that there are 3 servers over here for me. Let's say the requests on this server are loaded because of too many users who are using my website. So this server, what it will do is it will share some of the requests to this server, and some of the requests will be shared to this server, and in this way the loop continues of sharing. So this is known as resource pooling in cloud. Okay, so only one URL, but so many users are using that URL, so the servers are getting splitted into so many kind of stuffs, and then that is becoming like a pool of resource. So this is nothing but resource sharing or resource pooling also we can say. So that is what is happening inside cloud. That means that is one part of that thing which is happening inside it. So to say in a very simple terms, we want to host our application on the cloud, and the cloud in return will give us an DNS IPv4 address which we can share it with the entire world, and the entire world can access this. And the beauty of this is how many ever users are using my website, the services are not delayed. That means services are provided instantaneously. How it is possible? It is possible because of the internal resource pooling architecture which I showed over here. The server, there are 3 servers. One server, you get a request on one server, request gets completely filled, the request gets shared to another server. This server has also filled all the requests. This server sends to another server, and this continues in a loop. So this is all about the resource pooling thing. Okay, So all this resource pooling, management, scalability, reliability is a key characteristic of any cloud architecture. In the market today, Amazon Web Services provide these on a very advanced level. So the service or the response time for the user is very quick, right? So now we understood the after part from cloud to web. But what about this? This is the core part which we have to construct. So let us look into the details of this part first. This part is clear because after cloud, once we host our application on the cloud will give us an IPv4 DNS that we can share it with the web. That's it. That's done. That's simple as that. But the most important part is how from a local machine I am creating an instance in this cloud, and this cloud is performing all computational tasks, right? So what is the scene behind? So this is my local machine, and in a cloud, this is the cloud. For example, this is the cloud. So in a cloud there are many machines, many multiple machines who are waiting for my request. So basically, if I want my machine to communicate with any of these machines, I need some kind of authentication to be done, right? I want some kind of authentication to be done. Now how the authentication will be done is basically in form of key value pair. Okay, so there is an SHA algorithm which is running behind the scenes which will give me an SHA key value pair, SHA key value pair. This is an encryption algorithm which confirms that hey, the local machine which is giving you the request is verified by our IPv4 DNS servers. Okay, just understand this. The SHA key request, which the request from which you are getting on this local machine is being verified, in short. So this key value pair, in future video you will see it will be a .pem file. Okay, this will be a .pem file. With this key, what you can do is you will get mapped to any of these computers from here. Let's say that you got mapped to this computer and this computer is C2. So now let's see how the communication of you and C2 is being done. And this is a computer C2. Now this computer, it doesn't have any kind of things. It just has processor, that is it has a very good processor, it has very good memory, right? It doesn't have any kind of operating system installed in this. It doesn't have any kind of virtual environments. It doesn't have any kind of programming language softwares installed in it. You have to manually do that. So how to do it manually? So first what we can do is we'll get an option of selecting operating system. From Amazon Web Services only we'll get the option. So let's say that we install the Linux operating system here. Perfect. So Linux operating system has been installed in this system. Now what about the other parts, other softwares like Python 3 and all our requirements? How to do that? So in order to communicate with this Linux server, now this computer becomes a server because this will handle our requests, right? So how we can communicate, how we can send the files from this to this? We know that we will be using key value pair to authenticate it. Once that is done, there is one software known as WinSap. There is one software known as WinSap which will help us to communicate or transfer files from our system to the system of Linux. And this Linux system is the system which is present in this cloud. Once everything is done, this Linux system will generate an IPv4 DNS, which is nothing but our requirement. So this will make more sense when I will show you the live demo of deploying our application on AWS EC2 instance. Okay, so till then do learn more about cloud infrastructures and how SHA and how the WinSHA and WinSap, the PEM files, are working behind the scenes. In the next video, I'll show you how to deploy the application on EC2 instance. Okay. Hi. So in this video, we'll look at how to deploy our applications on by using EC2 instance of Amazon Web Services and deploy our machine learning algorithms. So for that, just go to AWS Management Console. So when you go over here, you will be having this AWS Management Console. Just click on it, and then if you are a new user, then please go to sign in and then fill in all the details and then press next, and then at the end they will ask you some 1 or 2 rupees to credit, so that your validity is so that you are a valid user. They basically want to check whether you are a valid user or not by crediting some very small amount of money, like 1 or 2 rupees, and providing the free service for 12 months. So Amazon Web Services, they provide free services for 12 months, but after that, if your instances, if you still continue to run their services, then they will add some more charges on it, because your free trial has been expired. Pre-free trial period, you can use all the services in free mode which they are providing. Post your free trial, if all those services are still working on your Amazon account, Amazon Web Services account, then those services will be charged. Just keep that in mind. Okay, so make sure that once whatever thing which you want to display in some web, if you want it for a short period of time, use free account. If you don't want it for a short period of time, you take the premium account of AWS. Okay, so after doing everything, so the console will look something like this: AWS Management Console. Okay, you just click on this AWS, you will be visited to the same page. Right. So now we will be going to EC2, as we are deploying our application on EC2, right? So now what we need to do is, we'll click on this launch instance, right? Launch instance. Just click on the launch instance. Go to EC2, right? And click on launch instance. And then over here you have to select your user, right? You have to select your operating system. So over here I am selecting Ubuntu. So if I hit search, so I'll be selecting this Ubuntu server 18.04 LTS, because this gives a good efficiency and results. So once that is done, you have to make sure over here that you select the right thing. You don't do anything if you are in free trial. You just click on next, configure instant details, because over here this is very risky. If you by mistakenly chose any of the other things, then you will be charged heavily. Okay, so whatever they are providing in free trial eligible, you just select that and just go on next, configure details. Over here also there is a lot of technical things. Don't do any kind of thing here, just simply next, add storage. Over here this is all about the storage. So how much RAM size do you want on your local system, which AWS will provide you, and everything of that kind. By default you just keep it as it is and just go and add to next tag. Then over here you can add tags in order to maintain your instances record. For example, I use AWS, so I already created some 3 or 4 instances, so it's becoming a clutter. I want to kind of get a very nice interface of my instances. So that is the reason why they will say you to add tags, so that the clutter is not found. So I'll just say this Flask demo gener app. This is my key, and my value will be app EC2 instance 2, right? So this is not mandatory. You can skip this. Just go and click on next, configure security group. Now this is important. So as over there I said that when you want to display your network, when you want to display your website to everyone on the web, you have to make sure that you give a public IPv4 address. So over here, this is the encryption algorithm, SSH and all. Just don't do anything to this part, but you can add a rule over here, and over here you select all traffic. From here custom you select anywhere, and that is all. Don't do anything else. Okay, then go to review and launch. You can just select, you can just see what all you used. So you used, and you are trying to, or you are requesting for an Ubuntu server. Then your instance type is T2 micro. This should be very carefully done. Okay, it should be T2 micro if you are using free trial. Otherwise you can select anything if you are having premium account. Then security groups, you can see SSH, all traffic, right? We selected the all traffic mode, right, just now in the last details. So everything you check once again and hit on launch. Now this is very interesting. As I said that in the previous video, I said you need a key value pair so that two computers can communicate with each other. Why do we need a key value pair? So that the other computer can get to know that, hey, this computer is being authenticated from my service provider who is providing the Amazon services. He has authenticated that the XYZ computer is secured, so I can communicate with it. So that is the reason why we have to generate a key pair. Just click on create a new pair. Then over here you can write some name to your key pair. Flask app general prediction. Okay, once this is done, just hit on download key pair. So a key pair will be downloaded in a PEM format, right? Now just simply hit on launch instance. So your instances will be launched, and just go to view instance. So already I created one instance on that. Now this is the new instance which is pending. So it will take some 1 minute or so. Now it will start running within some time. Fine. So just click on this. Just what you do is yeah, it started running. Just click on this instance, and over here you will get an instance summary. Now this public IPv4 DNS is the one where we will be hosting our entire web service or website which we created, right? So this is the most important part. Now what you do is, from here just go to instances, just select this, and then hit on connect. So once you hit on connect, you will get these details. Now these details are very important. Now I will show how to use these details. So for that, what you do is you have to install two softwares. So the first software is WinSAP for Windows. So you can go to your official website, WinSAP, and based on your operating system you can install your WinSAP service. So you can download it for Windows, you can download it for anything, you can do it. Okay, it's for Windows only. So you can hit on download now, and that is all. So another software which we have to install is PuTTY download for Windows. So you hit on this PuTTY, and then over here you can create on this PuTTY downloader. So from here you can see that whatever system architecture you are having, either 64-bit or 32-bit, according to that you can download PuTTY files from here. Okay, so from here only MSI Windows installer, if it's a 64-bit architecture, install this. If it's a 32-bit architecture, install this. So once you do that, you will have three softwares. One is PuTTY, one is PuTTYgen, and one is, so you will have three softwares. One is PuTTY, okay, and one is PuTTYgen, and one is WinSHA or SCP. So I will be opening this WinSCP software. So as I said that in the previous video, I said about this software, right, where if I provide the private key of my Amazon, of the service computer which is provided by Amazon, it will try to help me to share the resources from my file to their computer, right? So now we have to set the host name. So for host name, this is our host. So this is our public DNS. So this is our host. Copy this, paste it, and port number will be 22 by default. Username will be over here. Just go to here. This is your username, that is Ubuntu, right? So just type in Ubuntu here. Ubuntu. Just type in Ubuntu. And for password, you have to not type anything. Just go to advanced, and we download, and just go to SSH. Go to authentication. Then over here we have to give the private key. Now we downloaded a PEM file, right? But that is a PEM file, but we want the file in PPK format. So this WinSHA software will do it automatically by itself. So we downloaded this Flask app generate prediction.pem file, right? So we'll select this. So this PEM file will automatically get converted to PPK file. So over here it's saying, do you want to convert this OpenSSH private key to PuTTY format? I'll say okay. So it will ask me to say the location where I want to keep, right? So let's say that I will keep it over here, right? I'll say Flask app prediction, Flask gener app prediction _1.ppk. Save. Okay. Click on OK. So once that is done, now click on login. So click on yes. Now it is authenticating, and I think so, yes, the connection got established here. Okay, so now this home Ubuntu is the server of the Amazon Web Service, and this is my computer. Okay, so what happened just now is, as I said in the last video that my computer wants to transfer files to Amazon's server. So for that we require some kind of authentication, which was nothing but the private key. Okay, the private key, which was nothing but the private key value pair. With this I can establish the connection from my system to the system of Amazon. So that is what just happened now. So this is nothing but the system of mine, this is nothing but the system of Amazon. Okay, so now we have to be very careful over here. So this is the same thing which I wanted to show, right? This this is the folder where I have shared where I have kept all my the files which I will be using. So what I will be doing is simply I will be dragging and copying them over here. This will take some time, but this will be done quickly. So one by one we will be keeping the files from here to this place. If you want, you can also ignore this corpora file, but it doesn't matter if you keep or do not keep it. Just for a purpose of keeping every file, I'm just keeping it, because it is not mandatory to keep corpora files. Okay, it's not a problem though anyways, because in the code we have written the nltk.download stopwords and wordnet, right? It will automatically download in the same directory only by default. So you can skip this. That's not an issue. Copy the templates. You can also do it you can also do it directly in this way by selecting many files like this and copying them, right? So once you do all these files, I'll say you one very important thing in the app.py file which you have to keep in mind. So this app.py file needs to get edited. So you click on this file, right click, edit, notepad. So once in the notepad you go, and over here first you will not be having this line over here. You will not be having this line. Instead of this you will be having debug is equals to true, right? Debug is equals to true you will be having. So you have to remove this and you have to keep this. Host is equals to 0.0.0, port is equals to 8080. Why this I kept, this is nothing but the public IPv4 DNS. So we have to make sure that we keep this host only. Otherwise that will be a problem if we don't keep it. Otherwise that will not deploy our things. And then port must be 8080. Right? So this is one small change which you have to do in this code. Right? So just click on save and then close this. For rechecking, you can also check it if it's still 8080 only or not. Okay, yeah, it's the same. So you can close it. Now you can push this file over here. Yeah, so now all the requirements and everything has been transferred from this to this. Now this is the Amazon service, right? So over here we are having this option. This is the terminal, open terminal, and this is the open session in PuTTY. So we'll simply click on this. So directly, instead of doing so much things, we can directly use WinSHA software and directly log in into PuTTY's console also. So this is what we did. Now just simply write dir. So it will list all the directories which are there. Now what you have to do is you have to install some libraries and some dependencies here. Okay. So what you have to do is, first you have to install Python 3. So you do not have Python 3 over here. So if we just write Python, Python is not found. Okay, you have to install Python 3. So you will get some commands like this: sudo apt install Python 3. So you can copy them and you can install Python 3. Now once Python 3 is installed, you have to install pip. So for installing pip, I have this command sudo apt get update and sudo apt get. Don't worry, I'll just share this whole commands also and then just paste it. So it will install automatically the Python 3 pip file or the pip installer, package installer. So now we have the pip file. So now what we need to do is we need to install the requirements which are there. So pip install -r requirements.txt. Just place it and enter. Yeah, it will not be found because we have to write pip3. Pip3 install -r requirements.txt. You already, okay, you also have Python 3 installed. You can run Python 3 instead. Okay, sudo apt get sudo apt install Python 3. So I think so it is not installing the pip command here. Sudo apt install Python 3. Right, so yes. So what we need to do over here is, yeah, actually we didn't authenticate this basically. So what we need to do over here is we will close this entire thing. Yes. Now we will again open WinSHA. And then we will give our host name from here, SSH client, public DNS. And then username is Ubuntu, and then we'll go to advanced, and then we'll go to SSH authentication, private key. We have the private key over here as all private keys, Flask app generate prediction.pem. Yes, private key not over here. Prediction 2, save, OK, and then OK, and then login, and then just press, yeah, so it logged in. And then over here we are having this, and then yeah, so if I just type in Python 3, Yeah, so Python is already installed in my this system. So basically I just need to directly write pip install requirements.txt, install -r requirements.txt. so pip command is not found, so I have to install pip. So sudo apt get, so I have to write this command from here, sudo apt get update and sudo apt install python 3 install pip, enter. Yes, so it is saying unable to locate package pip. So let me just type in pip install requirements.txt, pip 3 install. Okay, pip install just copy this. You always get these kind of problems when you're working in AWS, so this is common. What? Command pip is not found but can be installed with sudo apt install python. So let's install it. Why? Yeah, so now it is installing the pip command. So whatever they are saying in the error, right, they are just suggesting the things. You simply use those lines only to you just simply use those lines and press on the terminal and then hit enter. Their suggestions are always correct and you can follow their suggestions. As you can see, I also followed their suggestions and it is importing the pip file for me, pip python 3 manager for me basically. So I think so, yeah, now I have it. Now I can write pip install -r, I can copy this command from here, pip install -r requirements.txt, and then I can paste it here and then enter. So when I do this, it will install all my dependencies. Yeah, so this is working fine now. And you get some kind of errors, but that couldn't find a version that satisfy NLTK from for NLTK double equals to 3.6.5. oh, so this is one error which I saw. So in order to solve this error, there's nothing to worry over here. What you can do is you can click on edit, you can go to notepad, and over here instead of 3.6.5 just give NLTK and then save this, right? So one file is got saved here, so you can recheck whether that got saved or not. Or simply what you can do is you can delete this, and then from here you can edit this, edit notepad, you can remove this 3.6.5 thing and you can save this. Once you save it, you can push it here, so requirements.txt file is coming. Now again you do pip install this thing, so now only NLTK will be installing now. Yeah, see, just NLTK got installed. So yes, some kind of things will happen like this way. That's nothing to worry about it. Okay. What is one more command which is there? So let me just see this. Edit. Yeah, nothing to worry as such. Now you can just write python app.py. Okay, so nltk.stem import porter stemmer. No module named as nltk. Oh, so this is saying PyChain requires Python 3.5 but running is Python 2.7. Okay, so Python 3. So I think so for pip we have to write sudo install. What were the commands? You can just press above up key and you can install this. So over here just write in Python 3 pip. So I think so this will fix the things. Just write y and hit enter. So this is installing Python 3 pip. Yeah, so we installed Python 3 pip. Now what we need to do is we need to change this again, right? So this requirements.txt will delete here, and over here we will edit the requirements.txt with the nltk is equals to nltk greater than or equals to 3.6, or let me just see the version of nltk. What is the version of nltk here? Edit in notepad++. We'll copy the exact version of nltk from here. Okay, this I think so. Yeah, let me just see nltk version. nltk version is 3.6.5. so let's copy this and over here we'll place it and we'll save this file. Okay, sorry, we'll save this file. Once this file is saved, we will push it here, and over here also we can see whether it is right or not. So yes, it is right. So we'll close this, and then over here we'll go to the putty console, and then we will write this command, that is pip install -r requirements.txt, and then enter. Now nltk will get installed now, I think, again. So if I write pip3 install pip3 install -r requirements.txt. Yup. So yes, so we have to write pip3 instead of simple pip. Okay, and I think this is working because nltk natural language toolkit is for Python 3 and more. Okay, so that was the reason why it was not showing. We installed Python 3 but we installed pip for Python 2.7. we have to install pip for Python 3, so that is why we wrote this command over here, pip sudo apt install Python 3 pip. Previously we just wrote sudo apt install Python pip, so it installed pip for 2.7.1, but we have to install pip for Python 3, so that is why we have to write sudo apt install Python 3 pip. Right, now if I write python app.py, I think so this should run now. This is again saying that there is no module named nltk.stem. So in line number 2 we have this error. So I'll just fix this, and in the next video we'll see into the deployment of this. So in the last video the error was very simple to solve. So basically if we just type in python app.py, so as we struggled a lot in earlier that it was Python 2, and basically because of that we installed the pip version of Python 2.7, right? But then we saw that nltk is not able to be installed in Python 2.7 because nltk gets installed only if Python version is more than 2.7, that is more than 3. Okay, so for that what we did, we did Python 3, so we installed Python 3, then we installed Python 3 pip, then we installed the requirements, and then again we were writing python app.py. So when we are writing python app.py, it is considering Python 2.7. That is why it is showing me that there is no module named as nltk.stem. So if I write python 3 instead of Python, now this will run. This see, it is running. So now this is running on this HTTP 80, right? So this is running on the AWS server now. Now in order to access it, what you need to do is you need to go to this SSH client, connect to your instance its public DNS, copy this on a new tab, paste it, and just hit enter. So now you will not get anything because this is not running on 8080 port. This is running on default port. So what you need to do, you need to keep colon, you need to keep colon 8080 and then hit enter. You see it runs, right? So this is all about the deployment of things on AWS EC2 instance. It is little bit tricky. You have to invest a lot of time in this, and we can see the prediction is also coming for us in this book genre description, and everything is working fine. The only disadvantage of now this will run only if this is coming here. If I shut this down, this will also shut down. Okay, so what, in order to make it more scalable, you have to use the premium version of this AWS EC2. Okay, so you can share this with anyone, that's not a problem. Port number must be 8080 because we define in our app.py that it should be 8080. So this is all about deploying our machine learning applications on EC2 instance of AWS. You have to be sure about the commands which you give in this PuTTY console. Don't worry, I'll be giving the commands list which you have to follow, and you can install them simultaneously. So I hope you enjoyed this.